All right, so let's talk a little bit about clay. A lot of people pottery videos do instruction style videos, tell you what's going on. I think for this video, I'm not going to bother with that. There's plenty of places you can get for instruction. What I am going to do is I'm going to talk about how I think about clay. I'm throwing it on the wheel. What am I thinking about, right? Yes, there's a shape, right? What's going to happen when I trim it, when I fire it, what color is it going to be? All of those things, yes. I think about that for sure. But there's something else that I think about that drives what shapes I make. It drives how I work with the clay. And how I work with the clay can be a bit different than some other people. And that's okay. But I think it's because of how I view clay that drives that. So, like all particles, this clay was made a long time ago. When these exact particles were made, I don't know. We will know. I don't think we can know that. But we know about 12 billion years ago, stars started to form. Gravity worked on the hydrogen, the helium, the very earliest of elements, compressed them. And as it got bigger, it got heavier and heavier, and there's more compression until we started getting stars about 12 billion years ago. And then, after a while, those stars kind of ran out of juice, if you will. And they exploded in what's called a supernova. And those supernovas were very important to life, because when you look at the energy required to make heavier elements, to fuse those protons into heavier elements, the energy in a star isn't enough to do that. There's got to be more energy put into it. And that's where the supernovas come in. Those supernovas explode with a massive amount of energy. And that energy is enough to form the elements that you and I are made of, and that this clay is made of. So this clay, just like you and I, was formed in the belly of an exploding star. And those exploding stars sent those elements all across the universe, where eventually they aggregated into our solar system and pinged around and went through a lot of bouncing back and forth in the solar system until things kind of settled in the orbits they are now. And this is really fun to mimic, and you can mimic this in the lab. And if you haven't asked your physics professor to mimic gravity so you can explain why all the planets are rotating in the same way, that's a fun experiment, a fun lab to do. But this clay has been at the bottom of the deepest oceans. It's also been at the top of the tallest mountains. And the forces that got it there are tremendous. The forces that move it around are massive, incredible forces. So when I put this clay on a wheel and start to move it around, I think about that. So I'm not afraid to push kind of hard. I'm not afraid to be a little bold with the clay and ask it to do what I want it to do. I don't have to be timid with it. It's endured many forces long before it even got to me. Now, as a scientist, I gotta say that's babble, right? These are just elements. They don't feel, they don't want, there's no desires to them. And that is correct. But as an artist, when I'm thinking about my art, that's how I view it. And that's important, because how you view your art will inform what you do with it. Excuse me. And so this is kind of the bonus of being both a scientist and an artist at the same time. Because it turns out the critical thinking involved in being an artist is the same critical thinking involved for being a scientist. The same problem solving. In art, there's a shape you want to make with the clay. There's something you want to do with the clay. So you got to think about it and figure out, first, identify what the problem is. What are you really asking? Kind of like exams questions, right? Don't stress so much about getting the answer. Worry about understanding the problem. That'll get you farther on the exams than anything else. So, identify the problem. What is the problem? Then, look at, alright, well, what do we know? What do we already know? What's going on? Then, identify, alright, what don't we know? What are we trying to do there? Once you figure out what you don't know, then you can say, alright, where can I get information for it? Or, what other life experiences have I had that would be something similar, so you can relate back to life experiences and figure and use those life experiences. This is why it's difficult sometimes for students, current students, that much of their life has been online. It hasn't been a real experience. So that can make things difficult. However, not impossible. So you can relate it back to a life experience. You can look to say, alright, where can I go to figure out, to find the information for what I don't know? Find that information and then make sense of it. Once you've made sense of it, you can try different things. Scientific process, if you will. So, when I want to make a certain shape, vase or something like that, and it doesn't work, I try something else. And in its most basic, that is the scientific process. You're trying something out, you're seeing if it works, and if it doesn't, you try something else. And that's the same process with clay. And it's the same process with art. This is why the sciences and art are so important. Both of them. Not just one in a module, in a silo. So not just one, but both of them together, because they both reinforce the skills required for one another. So that clay, formed in the belly of a star, it's been on the top of mountains and the bottom oceans and in deserts and forests. It's been moved around. And so I'll be quite bold with it sometimes. It's kind of like, that clay is kind of like a frisbee. And all together, so when you lay them on top and stretch it and do it just right, it becomes quite strong. Because when I'm doing this, I'm seeing the particles in my mind, and I'm seeing what the particles are doing when they move through my fingers. What's happening with the physics of the wheel turning. So for example, when I squeeze up here, that puts some pressure on it, and so it'll start to twist if I squeeze too hard or too fast or without enough water to make that clay slip and slide underneath the fingers. So once I make that clay slip and slide, using the appropriate amount of force, I can make what I want to make. All from that same problem solving, using the scientific method, and all with an understanding of how these particles were formed in deep time over incredible periods and in incredible ways.